Hello friends, this is VM. In today's lesson, I'll be teaching you about Hund's rule. What is Hund's rule? Hund's rule was stated by German physicist Friedrich Hund in the year 1925. Hund's rule states every orbital in a sublevel or subcell is singly occupied before any orbital is doubly occupied. The electrons in all the singly occupied orbitals have the same spin. Explanation: orbitals are the location of electrons in an atom. If two or more orbitals of equal energy are available, electrons will occupy them singly before they start pairing up. The reason for this is that the electrons tend to remain unpaired as far as possible. So what does it mean? It means all the orbitals get filled by one electrons in each. Electrons will not start pairing up unless all the orbitals get filled. And occupied orbitals have the same spin electrons. How does electron spin? So the electrons in an atom not only move around the nucleus, but they also spin about its own axis. And the electrons either spin on its axis clockwise or upward direction, that is called spin up, or they spin anticlockwise or in downward direction, which is called spin down. So all the singly filled orbitals must have the same spin. So friends, here I have drawn one diagram for you to explain the Hund's rule. In this diagram, you can see the first element is carbon and its atomic number is 6. As above stated, the electrons will fill in the orbitals according to the increasing order of energy level. So this is going to be like this, means 1s2 will fill and then 2s2 and then 2p2. So first the 1s2 orbital will fill with 2 electrons. Then the 2s2 orbital will fill, and then now the Hund's rule will apply for 2p orbitals. Here you can see this subcell has more than 2 orbitals and the electrons will fill singly in each orbital and they will not pair up. And you can see both the electrons are in upward direction, means they are having the same spin, that is the up spin, or they can also have the down spin. But the electrons will not fill in this way, means one will have up spin and another will have down spin, or the electron configuration will not be like this also, means the electrons will not pair up unless all the orbitals get filled with one electron in each. Now we can see for nitrogen, its atomic number is 7 and the electron configuration is 1s2, 2s2, 2p3. So for nitrogen also the 1s2 orbital will fill first, then 2s2 and the 3 electrons of 2p will fill 1 in each orbital. And you can see all the electrons are in upward direction. They are having up spin, or they can also be like this, means they can also have down spin. But the electrons will not fill in this way, means they will not pair up unless there is empty orbital or all the orbitals get filled with 1 electrons in each. Now we can see for oxygen, the atomic number of oxygen is 8 and its electron configuration is 1s2, 2s2 and 2p4. So here 1s2 orbital will fill first, then 2s2 and the 2p subcell that has 4 electrons. Each electron will fill first singly in the 3 orbitals. Then the fourth remaining electron will pair up with the first one. But the electron configuration is not going to be like this. Means they will not pair up unless there is one orbital is left. There it still remain empty. So friends, you can see in this diagram, this configuration is correct. This is also correct. This configuration is correct. This is also correct. And for oxygen, this is correct. But this is wrong. This is wrong. This is wrong, and this is also wrong. So here is the chart. So friends, you can draw this chart in your notebook. And now here are some questions regarding what I have taught you in this video. Please read and answer them in the comment sections. I will give thumb sign to the correct answers. Thank you for watching my video. Friends, if you like my video, please subscribe the channel.